think that's 4, not 8.
Yeah.
4.
So that's the way it's set up.
Set 4 examples.
So the question is in there, yeah. Let's see.
Well, I think it's more the whole setup isn't as clear. So it's you see you're getting these A values and stuff, and you're getting these limits, but they're for a single sample. So your sample should be close to the grand mean. Is it outside these? Is it outside that? Is it above? Is it below? And the bigger the sample size, not the 8 samples, but the 4, the more likely you are to be to the middle. So actually, when I said this takes account of the S over root n, actually this includes the sample size as well. So it's kind of the T S over root n is kind of captured all together by this. But it's definitely 4 here, not the 8. So it says sample size, not number of samples. So it is definitely the 4, not the 8. So we'll calculate some numbers now. So we have x bar minus a 0.025w, we'll do that one. X bar plus a 0.001 w bar equals same thing, a, oh shit, should probably 0.25. X bar minus same thing equals. So these are our 4 things, and actually you don't have to remember which is in or an outer because just the numbers will line up. So that's okay. But these are the inner ones.
So you will have to remember that bar formula, so really one chance.
Yeah. You got one.
Let's get W there.
It's just in the formula. Oh, how do I get it?
Yeah.
The average of the W's.
Average of W. Yeah.
X bar not 80
Yeah,
there.
yeah, there's 80.
Oh, sorry, yeah. Sorry, thanks. Take that there. 2.02.
If you use the 16.5 down by mistake, it changes it.
Yeah, I'd be wrong.
But it doesn't change the total outcome though.
No, it will. You'll see. No, I will, because everything will be too low, and they'll all look above. They'll all be too big. Like this is, yeah. You'll see it's wrong. Now you'll still get. You'll obviously lose some marks there. You'll have to lose some marks also for presenting something that's clearly wrong. Usually, like, if something is clearly, so they'd nearly all be above the average. That's impossible. Or you'll have 2 of them below. 2 of them below. It should look dramatically wrong.
Yeah, I suppose. Yeah.
that's your axis, sample mean against thing. So you have, this is what I'll be happy with, x bar bar anyway, symmetrically above and below the inner control limits. So upper inner control limit, lower inner control limit. Lower outer control limit, upper outer control limit. And now start throwing these numbers in and just get them in the right place. Now you might have to write in these values to kind of be clear in your head. So 20.5, it's bigger, or maybe that's 1, 2, 3, 4, 5, 6, 7, 8. So 20.5 is above this, but below this. So anywhere between those two is fine. Next one, 21.25. Now it's above the grand mean and it's bigger than this, but it is smaller than this, so that's up in here. That's a warning.
Can you go back to that first one there, that first X?
So if you can't see where we're getting it, you're going to have to label these with these values. So this one is 18.8. Upper inner control limit will be this one, 21.1. 16.5, the other one will be here. The smallest one is this one.
Like the smallest value you get is always the lower outer control
Yeah,
limit.
and the biggest
highest
one-
value is always
yeah.
your upper.
Yeah, and work from there. So if it's kind of fair enough, like it's kind of,
Yeah,
it's
I
a
know.
bit messy, that's probably a good
I
idea.
see there.
Next one is 16.5. That's right on the money. Now what I'll do with that is almost a steward's inquiry, because that has rounding. That has rounding in it, so I'm just going to do this again. And just take an extra, so it's 033. So it's actually just inside. It's okay. So I was just double checking. It shouldn't.
It shouldn't be down lower. It should be down the bottom, shouldn't it?
The second line in the book.
Oh shit.
See, I mean, it'll actually be outside.
So actually, it is outside. Yeah. Thanks.
Right, check it,
Definitely, you're right. It'd be a bit of a fluke for it to land on a line. So you just, if it does, it does. I don't. Fairly sure it doesn't. So it's out of control here already anyway. So you've got two consecutive outside the inner control limits. We'll keep going. 19.8 between these two. And 11.65. Oh, that's miles off. That's down here. It's outside this. So it's out of control twice. This one is all over the shop.
Is that sample 3, is that not actually inside, is it? It's just above the 16.5.
No, it's 16.5, which is less than this.
0.003 Pro.
It's bigger, it's
That's big.
0.033 bigger than 16.5. So that means it's closer to 18.8.
Yeah, that's what I think.
Oh yeah, you know what I mean? Or am I looking at it wrong?
This
No,
is
I haven't heard of it.
15.5003.
Yeah, it's bigger than 16.5, so it's closer to the X backer.
No.
The other
No,
side.
no, no. Oh, sorry, that's, oh yeah, that's point, yeah.
There's no way.
Oh, I get it now.
Okay.
Come on.
The sixth one, 17.5, that's safe. And the 7 one, 23.95, that's gone as well. So this one is really all over the shop. And 19.25. State giving reasons, so actually just three, it's out of control and there's three ways. It says reasons, so you probably should give all of them.
Your reasons then will be whatever sample is outside.
Yeah, I'll show you how you'll write that now. So, out of control. Samples 2 and 3. Outside inner control limits. Sample 5 outside outer control limit, and sample 7, is it? Yeah. So usually it's under control. Pick some weird numbers to get it under control. And it's a statistical kind of control, it's a weird kind of a thing. I won't go too
So say 2 consecutive ones in the inner control ones, or 1 outside.
Or 1 outside. So this is 3 times outside.
So
So
like, let's say 1 just outside the outer, next one wasn't, next one is. Okay.
1 out, this out. Say just 1 out,
Yeah.
and say this out and this out. That's fine.
Yeah, as long as they're not.
consecutive.
Yeah. Right.
Yeah. So the only thing that would really change here would be I could give you less samples and ask you to calculate all the means and ranges. I'd rather this one myself. That's about the only thing that would change. Any more questions on this?
So you know, 4.8,
Yeah, fair enough.
so the 4.825, is that the same throughout?
Yeah, that was W bar.
That's the N number, is it?
The W bar. The average of the ranges.
In part B, we were after the 95%, yeah. But part C, we have to do the 95 and the.
Yeah.
And if we were asked to do the 90, would we ever be asked to do the 95 and 90? Is that what you were saying a while ago?
In part B,
Yeah.
oh, you could be asked for 2 of them. I wouldn't really be a fan. If you can do 1, you can do the other one as part of that. Okay, question 2. A study looking at the income distribution of those working in the IT sector, and economists surveyed and recorded starting salaries in thousands of euros in a sample of 60 positions. Draw an O guide. Right. So the O guide is the one where you plot frequency against less than X, or what's called cumulative frequency. There are different things that can happen here, so you have to look at the different questions. Pretty much everything that can be asked is in either the samples, the examples we did, or the exercises. So you're looking at X less than and frequency. Now the first one, it's very handy to get, and oh yeah, the other thing is, see the way this is messing around with 19.5, 20.5? That won't happen. It'll be 10 to 20, 20 to 30, 30 to 40. There'll be no messing around like that, okay? And it's handy, if you're doing the O guide, to have the first one less than the first number 10. How many of them are starting at less than 10?
0.
0, yeah. And then we'll go all the way up to 80. So the next question is, how many of them make less than 20? 20. How many of them make less than 30?
56.
Now does everyone see where we get 36 from?
16 and 20.
Yeah. So you got 20 of them are less than 20, so they're less than 30 and or plus 16. And then you just keep adding the numbers up. So plus 5 in the next, plus 6 in the next, plus 5 in the next, plus 4 in the next, plus 4 in the last. So you'll need to know to do that for an ogive. Now the ogive is tricky without the graph paper, but I'll give it a go. So you're applying f versus x less than.
Are they all come the same layout then, like draw the old guy, do the thing? Or-
No, I have, there's a bit of, yeah, you have different things happening here. So I'm going to go in from 0 to 60. I can go in 5s or 10s really, is about all I could do. I think just for, I'll go in 10s here. Let's keep going, let's make it nice. See how good I can do it. And this one will have to go up to 80. So again, I'll probably have 8 boxes along the bottom. If I've only 4, you know, you do graphs in other modules. You know, I mean, how you scale it. Use 1, 2s, 5s and 10s, don't use other things. Use reasonable scales, play around, have a mess around. Do that. So this would be x less than. This is f. And going in 10s. So I'm up to 60. I'm going to get 60. So 0. 10. Shite. 10, 20, 30, 40, 50, 60, close enough. And then this one is going up to 80, so I go 10s. 10, 20, 30, 40, 50, 60. 70, 80. Okay. How many less than 0? 0. How many less than 10? 0. And then you just graph this. How many less than 20? 20. And less than 30? 36. And less than 40? 41. And less than 50, 47. And less than 60, 52. And less than 70, 56. And then all of them less than 80. You should try and put a bit of curve in this. It has to always be going up. Oh yeah.
You never try no one going down, will you?
Huh?
You never throw one and going down, will you? In the exam, it'll never be going down like with that.
No, it's always
Never.
going up. This is always going bigger and bigger and bigger. This is cumulative. That's the, okay, that's, I thought I was going great there, that's crap. It's easier to graph paper anyway. Okay. Use the ogive to estimate the median. Now, you want a rough understanding of what the median is. What's the median?
Yeah, it's going
Yeah.
No, that'd be the most.
difference between the upper and the lower one.
Yeah, it's the number in between the big half and the small half. So you can kind of think your way into this if you can't do it straight away. So how many data points do we have? 80. So what would half kind of be? 40. So you want to go to No, not 80.
50.
No, start again. There's 60, yeah. So what would half of them represent? 30. So you go across from 30 here. So obviously you don't have it here, so you do it here. So this will be your n over 2. Half the data. Go across to here. Obviously again, easier with graph paper down to here. And I'm going to call that 24.5, whatever. So this is, so you've got 30 of them have less than 24.5 and 30 of them have more than 24.5, so that has to be the median. And it's approximate.
Is there a way of calculating this, or you have to get it off the graph?
Yeah, so I think I might be throwing, I could for example be throwing something like use the OGIVE or otherwise. So the otherwise is without graph, and I'll do that up here. In this question you had to use the OGIVE though. But I might be giving you that option. So the other way is something like